In this video, we're going to focus on imaginary numbers, how to simplify it, add, subtract, multiply, divide, how to solve equations involving complex imaginary numbers, and how to graph it. So let's begin. So what exactly is I? You need to know that I is equal to the square root of -1. I squared is equal to -1. I cubed is -I, and I to the fourth is 1. So here's why. Let's prove I squared. So if I is the square root of -1, if we square both sides, you get I squared on the left. And when you square root a radical, the radical disappears because there's a 2 here. That's the index number, so you just get -1. Now I cube is the same as I squared times I. And we know I squared is -1, so that's how we get -I. Now I to the fourth is equal to I squared times I squared. And since each I squared is -1, -1 times -1 is +1. So make sure you know these four, because from these four you can find everything else. So let's say if you want to calculate I to the fifth power. That's the same as I to the fourth times I. I to the fourth is 1, so 1 times I is simply I. Let's say if you want to find I to the seventh power. That's I to the fourth times I cubed. I to the fourth is 1. I to the third is -I, so this whole thing is -I. Let's say if you want to find I to the 10th power. That's the same as I to the 8th times I squared. I to the 8th is like I to the 4th squared, because 4 times 2 is 8. I to the 4th is 1. 1 squared is 1, and I squared is -1, so you end up getting -1. Now, is there an easier way to get the final answer instead of showing our work as we've been doing right now? It turns out there is. So, we know that I is -1. I squared is -1. I mean, this is square root -1. I cube is -I, and I to the fourth is 1. This is the same as I to the fifth. That's the same as I to the sixth, seventh, eighth, and you can keep counting it. This is the same as I to the ninth, I to the 10th, I to the 11th, I to the 12th. And then it keeps going. This is I to the 13th, I to the 14th, I to the 15th, and I to the 16th. So let's say if we want to calculate I to the 15th. What you want to do is divide 15 by 4. How many times does 4 go into 15? If you divide 15 by 4, you're going to get 3.75. So that means 4 goes into 15 3 times. But you want to focus on the remainder. 4 goes into 15 3 times, but what's remaining? I to the third is remainder. Like 3 is the remainder. So therefore, I to the 15 is the same as I to the third. And I to the third is -I. And that's how we get this answer. Let's say if you want to find out what I to the 14th is. So how many times does 14 go into, how many times does 4 go into 14? 4 goes into 14 at least 3 times, because 4 times 3 is 12. And 14 minus 12 is 2, so your remainder is 2. So I to the 14th is the same as I squared, which is -1. So what you want to do is divide your exponent by 4. And this will give you 3.5. That means 4 goes into 14 at least 3 times. And if you take 0.5 multiplied by 4, that gives you 2. That's your remainder. And so that's how you get I to the 14 is equal to I squared, which is -1. So let's say if you want to calculate I to the 11th. How many times does 4 go into 11? 4 goes into 11 2 times. Because 4 times 2 is 8. So the remainder is 3. I to the 8, which is a multiple of 4, is going to be 1. Remember, I to the 8 is basically I to the 4 squared, which is just 1 squared, which is 1. So therefore, I to the 11th is equal to the remaining part, I to the 3rd. And I to the 3rd, we know it's just I. So let's say if you want to find I to the 25. Another way you can see it is, what's the highest multiple of 4 next to 25? So we have 4, 8, 12, 16, 20, 24. 25 minus 24 is 1. So the remainder is really 1. I to the 24, or anything to the multiple of 4, is 1. So basically this is equal to I. So let's say if you want to calculate I to the 38. What's the highest multiple of 4 that goes into 38? Or how many times does 4 go into 38? 4 goes into 38 9 times. So the highest multiple of 4 is 36. That's just under 38. So 38 minus 36 is 2. I to the 36 is 1, and I squared is negative 1. So the answer is just negative 1. So let's say if you want to calculate I to the 60. 60 is the multiple of 4, so it's just 1. If you want to calculate I to the 75, what's the highest multiple of 4 next to 75? This would be 72. 4 times 18 is 72. And the remainder is 3. So we have 1 times I to the 3rd power, and I to the 3rd power is the same as negative I. So let's say if you want to find I to the 202. 200 is a multiple of 4. And so the remainder is 2. So this is going to be 1 times I squared, which is negative 1. So let's say if you want to find I to the 303. 300 is a multiple of 4, and the remainder is 3. So I cubed is negative I. So hopefully you see the pattern of how to simplify imaginary numbers, especially when they become very large. So I've mentioned a few methods that you can use to simplify it. Just pick the one that you feel comfortable with. But let's move on to our next topic. So let's say if you want to add or subtract imaginary numbers. So let's say if you're given this problem. What's the answer to it? So what you want to do is add the real numbers, 4 and 2. That gives you 6. And then add the imaginary numbers, 3i plus 5i. That's 8i. That's all you got to do for that problem. And it's in standard form. Standard form is basically a plus bi form. You write the real part first, and then you write the imaginary part afterward. Now what about subtracting imaginary numbers? So let's say if you have 3 plus 7i minus 2 minus 4i. So there's nothing in front of the parentheses on the left side, so we can just open it. This is 3 plus 7i. Here, distribute the negative sign. So it's negative 2 plus 4i, because you have two negatives here. And then combine like terms. 3 plus negative 2 is 1. And 7i plus 4i is 11i. Try this one. So let's say if you have 8 times 2 plus 5i minus 3 times 4 minus 7i. So what you want to do is distribute the 8 and then the 3. So 8 times 2 is 16, and 8 times 5i is 40i. Negative 3 times 4 is negative 12, and negative 3 times negative 7i is positive 21i. So now add like terms. 16 plus negative 12, or 16 minus 12, is 4. And 40i plus 21i is 61i. So now let's talk about how to multiply imaginary numbers. So let's say if you have 3 plus 7i times 2 minus 5i. What would you do? So here you have to FOIL. 3 times 2 is 6. 3 times negative 5i is negative 15i. And 7i times 2 is 14i. And 7i times negative 5i is negative 35i squared. So negative 15 plus 14i, that's negative 1i. And I squared is negative 1. So what we have is 6 minus I plus 35. Now we can add the 6 and the 35. 6 plus 35 is 41. So our final answer is 41 minus 1I, which is now in A plus BI form. So try this example. Let's say if you have 8 minus 3I times 4 plus 5I. How would you do it? So 8 times 4 is 32, and 8 times 5I is 40I. Negative 3I plus 4, that's negative 12I, and 3I times 5I is negative 15I squared. So let's combine like terms. 40 minus 12 is 28, and I squared is negative 1. So we have 32 plus 28I plus 15. So let's combine 32 and 15. That's 47, and then plus 28I. So that's our final answer. So what if you get a problem that looks like this? 3 plus 2I squared. What you want to do is rewrite it as 3 plus 2I times 3 plus 2I. So then you want to FOIL. 3 times 3 is 9. 3 times 2I is 6I. And 2I times 3 is 6I. And 2I times 2I is 4I squared. And then follow the same steps. So 6I and 6I is 12I. 4I squared is negative 4. 9 minus 4 is 5. So we get 5 plus 12I. Now let's say if you have a cubic function. Let's say you have 3 minus 2I to the third power. So that's 3 minus 2I times 3 minus 2I times another one. So you want to FOIL 2 at a time. Let's focus on the first two. 3 times 3 is 9. 3 times negative 2I is minus 6I. Negative 2I times 3, that's negative 6I. And then negative 2I times negative 2I is positive 4I squared. So this is 9 minus 12I minus 4. 9 minus 4 is 5, so we get 5 minus 12I. And we're going to take this result, multiply by the third one. So we get a FOIL again. So 5 times 3 is 15. 5 times negative 2I is negative 10I. And then negative 12I times 3 is negative 36I. And then negative 12I times negative 2I is positive 24I squared. So this is 15. Negative 10 minus 36 is negative 46I. And 24I squared is negative 24. So 15 minus 24 is negative 9. And then minus 46I. So that's the answer for that one. Now the next example is multiplying by the conjugate. So let's say if you have 2 plus 5I, and you want to multiply by its conjugate, 2 minus 5I. So FOIL it again. 2 times 2 is 4. 2 times negative 5I is negative 10I. 5 and 2 is positive 10I. And 5I times negative 5I is negative 25I squared. So the two middle terms cancel. So you get 4 plus 25 because I squared is minus 1. So your final answer is a real number, 29. So anytime you multiply by the conjugate, the two middle terms will cancel. So we're going to do this the shortcut way. So 3 times 3 is 9. The two middle terms will cancel, so we're going to multiply the last one. So 4i times negative 4i is negative 16i squared, which becomes positive 16, and you get 25. It's always going to work that way if this is plus and this is minus. Now I do want to mention something. So if you have this, you have to FOIL. You have to do 2 plus 5i times 2 plus 5i. But let's say if you have 2 times 5i squared. Notice that here we have a plus sign, but here it's multiplied. For this term, you don't have to FOIL. You can square both sides. 2 squared is 4. 5 squared is 25. And I squared is just I squared. So you get 100 I squared, which is negative 100. So because the 2 is multiplied by the 5i, you don't have to FOIL. But because there's an addition sign between the 2 and the 5i, you do have to FOIL. If there's a plus or minus, you have to FOIL. If it's multiplication or division, you don't have to FOIL. I just want to go over that topic. So now let's talk about dividing complex numbers and simplifying it to standard form, a plus bi. So let's say if you have 3 plus 2i divided by 5 minus 3i, and you want to simplify it. Multiply top and bottom by the conjugate of the denominator. Since the denominator is 5 minus 3i, the conjugate is 5 plus 3i. Now, we know how to multiply by the conjugate, at least the shortcut method. 5 times 5 is 25, and negative 3i times 3i is negative 9i squared. For the top, they're not conjugates of each other, so we have to get all 4 terms as we FOIL it. 3 times 5 is 15, 3 times 3i is 9i, and 2i times 5 is 10i, and 2i times 3i is 6i squared. So on top we have 15, 9 and 10 is 19i, 6i squared is negative 6, and negative 9i squared is plus 9. So 15 minus 6 is 9, so we have 9 plus 19i. On the bottom, 25 plus 9 is 34. So to put it in a plus bi form, we could separate it into 2 fractions. So a is the same as 9 over 34, and bi is 19 over 34i. So now it's in a plus bi form. Let's try another one like this. So let's say if you have 4 plus 6i, and it's divided by 2 minus I. What we're going to do is multiply top and bottom by 2 plus I. So on the bottom, 2 times 2 is 4. Negative I times I is negative I squared. On top, 4 times 2 is 8. 4 times I is 4i. And then 6i times 2 is 12i. And 6i times I is 6i squared. So 4 and 12 is going to give us 16, and 6i squared is negative 6. And negative I squared is just plus 1. This is negative times negative 1. So 8 minus 6 is 2, and 4 plus 1 is 5. So we're going to separate into 2 fractions. So it's going to be 2 over 5 plus 16 over 5 times I. Now what if you get a problem that looks like this? 7 over 5 plus I. What would you do? So you need to do the same thing. Multiply top and bottom by the conjugate of the denominator, not the numerator. So on the bottom, 5 and 5 is 25. I times negative I is negative I squared. On top, we got to distribute the 7. 7 times 5 is 35. And 7 times negative I is just negative 7i. So we can't really do much to the numerator. There's nothing to combine or simplify. On the bottom, we could replace the negative I squared with positive 1. It's negative times negative 1. So that becomes positive 1. 25 plus 1 is 26. So we now have this. And then just separate it into 2 fractions. So 35 over 26 minus 7 over 26 times I. Alright, so now let's try this problem. So let's say if you have 8 plus 3i times 5i. So in this example, we only have 1 term in the denominator instead of 2 terms. If you only have an imaginary number in the denominator, all you got to do is multiply top and bottom by I. So on top, let's distribute the I. I times 8 is just 8i, and 3i times I is 3i squared, but there's a plus sign between it. And 5i times I is 5i squared. So 3i squared is negative 3, 5i squared is negative 5. So I'm going to rewrite it as negative 3 plus 8i over negative 5. So negative 3 divided by negative 5 is just 3 over 5. 8 divided by negative 5 is negative 8 over 5 times I. So now it's in standard a plus bi form. So let's say if you have 7 over I to the third. what you want to do is multiply top and bottom by I. You want to get rid of any imaginary numbers in the bottom. So you get 7I over I to the fourth. Now I to the fourth, we know it's 1, so this is 7I over 1, which is simply 7I. So now we're going to focus on solving equations that deal with imaginary or complex numbers. So let's say if you have 3x plus 5I, and let's say if that's equal to 9 plus 20yi. How would you solve it? You need to know what's real and what's imaginary. Anything with an I is imaginary. So we're going to set those two equal to each other. So 5I equals 20y times I. These numbers, they don't have an I, so they're real numbers. So 3x is equal to 9. And then solve these two equations separately. So on the equation on the left, we're going to divide both sides by 3. So 9 divided by 3 is 3. On the other equation, to solve for y, we're going to divide both sides by 20i. So on the right side, the 20's cancel and the i's cancel, so we're just left with y. On the left side, I cancels. 5 divided by 20, or if you divide it backwards, 20 divided by 5 is 4, but it goes on the bottom because you divide it backwards. So y is equal to 1 over 4. So now let's try this one. 2x plus 3i is equal to 8 plus 9yi. So these are the real numbers. So let's set 2x equal to 8. And the imaginary numbers are the ones that contain I. So 3i is equal to 9yi. So on the left side, let's divide by 2. So 8 divided by 2 is 4. On the right side, let's divide by 9i. So the i's cancel and the y's cancel. The 9's cancel. Here I cancel as well. If we divide it backwards, 9 divided by 3 is 3, but it goes on the bottom. And so our answer is 4, 1/3 as an xy ordered pair. So now let's say if you have this equation, x squared plus 25 is equal to 0. How would you solve for x? We're going to talk about two ways. So first, let's move the 25 to the other side. Let's subtract both sides by 25. So x squared is equal to negative 25. Now what you want to do is take the square root of both sides. So x is the square root of negative 25. Now square root negative 25 is the same as root 25 times root negative 1, because 25 times negative 1 is negative 25. And you also get plus and minus, by the way. So the square root of 25 is 5, and the square root of negative 1 is I, so you get plus or minus 5i. Now let me show you another way to get that same answer. Let's say if you have x squared minus 25. This is a difference of perfect squares. To factor it, it would be x plus 5 and x minus 5. And then you have x plus 5 is equal to 0, x minus 5 is equal to 0, and if you solve for x, it's negative 5 and 5. Well, if you want to factor a sum of perfect squares, the only way to do so is with imaginary numbers. It's x plus 5i and x minus 5i. Because 5i times negative 5i is negative 25i squared. And I squared is negative 1, so negative 25 times negative 1 is this number, positive 25. So what you do here is you set each one equal to 0. And so x is equal to negative 5i, and x is equal to 5i. So you get the same answers, so you can factor it if you want to solve that equation. So let's try this one. 4x squared plus 36 is equal to 0. So let's move the 36 to the other side, where it becomes negative 36 as you move from the left to the right side. So now we're going to divide both sides by 4. So x squared is equal to negative 9. And now we're going to take the square root of both sides. So x is plus or minus root negative 9, which is plus or minus radical 9 times radical negative 1. And the square root of 9 is 3. And square root of negative 1 is I, so we get plus or minus 3i. Now the last topic that we're going to talk about in this video is graphing complex numbers. And that's a terrible graph. My lines are never straight. So this is the imaginary axis, and this is the real axis. So let's say if we wish to plot 3 plus 2i. So you go 3 on the x-axis, which is over here, and 2 on the y-axis, which is basically the imaginary axis, and you find where those 2 points meet. So here it is. Let me put that in a different color. So 3 plus 2i is over here. It's 3 on the real axis and 2 on the imaginary axis. So let's say if we wish to plot 2 plus, actually not plus, but 2 minus 4i. Where would you plot it? So 2 is right here on the real axis, and negative 4i is down here. So those 2 points, they intersect at this point here. So that's 2, negative 4i. So let's say if we want to plot negative 3 minus 5i. So negative 3 is over here, and negative 5i is down over here. So those 2 points meet in that direction. So that's how you plot it. Just keep in mind the real axis is like the x-axis, the imaginary axis is the y-axis, and you plot it as an ordered pair. So that pretty much concludes this video. That's complex numbers and imaginary numbers in a one short video review. So that's it. Thanks for watching this video, and have a great day.